Today in this session we will discuss about building quantum ML models using IBM QSKIT. Actually, quantum computing technique is not a new technology as compared to okay, madam. Now audible. Am I audible, madam? Oh, yes, madam. Power problem. Yes, madam. Yes, just now itself, just power off. Okay, just 1 minute, madam. 1 minute. Sorry for the interruption, madam. Now, good evening, one and all. Today we are discussing building quantum ML models using IBM QSKIT. So first we will see about the quantum computing and so why we are incorporating this, combining these machine learning models along with the quantum computing. So first we will see the difference between traditional machine learning techniques, machine learning model to this quantum computing incorporating into it. Okay, next, first, normally in usual data, traditional data, the data is in the form of zeros and ones, as we know that. Okay, in this FDP session, first we will see the main contents, what we focus on. Just I will read out. Understand the basics of quantum computing. just about the what is meant by quantum computing, what are the quantum principles we are using in machine learning, deep learning, or AI models. Next, explore quantum machine learning concepts. So quantum machine learning together concepts. So already in the last sessions you have seen about the quantum neural networks and quantum support vector machine. In this session, I will discuss about the quantum convolution neural network. Learn IBM QSKIT framework. Okay, this IBM QSKIT framework is very useful. Okay, so it is open source up to 1 month, up to some data, up to some execution we can do, some project we can do up to some limit. Okay, after that we have to pay some amount to the IBM cloud. Next, quantum CN we will discuss. Next, explore future applications and research directions in this quantum ML models. Together, quantum computing and ML DLA technology together, that also we'll discuss. Introduction to quantum computing. First, we will see qubits versus classical bits. Classical bits, we know the data is in the form of zeros and ones only, in the bits binary format. In classical computers, the smallest unit of data is bits. That is just switch on and off like that, 0 or 1. That's it. Qubits, when we have taken quantum bits, this qubits also nothing but quantum bits. In quantum computers, the basic unit is qubit. Here the possibilities are not only 0, 1 like classical bits. We are having many more possibilities. Okay, mainly superposition, entanglement, like quantum principles we are using in here. Along with machine learning techniques, when we combining with the quantum computing, in quantum computing we are using these techniques: superposition, entanglement, and interference. What is meant by superposition? Superposition is nothing but generally we are having either 0 or 1, only two possibilities. But qubits are not like that. Superposition is nothing but we are having plenty of possibilities. In 0 to 1, there are n number of values. So any number, any possibility can be taken. So in classical, there is only on of 0 or 1, only two possibilities. Here you are having many number of possibilities from 0 to 1. It is like a coin. Just take a coin example. When you are spinning a coin, just imagine while it spins, it's in both heads and tails states. Both the states it is having. Only when you catch it, do you see the final definite result, definite some exact result you can. It is just spinning. So it is 0 or 1, 0 to 1. There are plenty of possibilities are there. So those that particular possibility may be 0.1, 0.112, 0.123, 0.21, like that. There are plenty number of possibilities are there in superposition. Superposition lets quantum computers explore many possibilities at the same time. We can say this as massive parallelism. That means parallelly we are having plenty of possibilities. That's why this quantum technology, why we are using in machine learning, is nothing but this benefit only, these principles benefits only. So that at a time we can using AI also, we can any example if you have taken chatbot or any other some games if you have taken. Okay, there at a time you can go through only Sudoku game or any game if you have taken. At a time, AI also can do only one position. So it will do fast. Definitely, it will do fast. AI really that is acceptable. But at a time, we can go through a single possibility only in AI, using AI. So here quantum computing, the main why we are preferring this is the number of possibilities at a time. That is the main thing of the superposition. That is one by superposition. Next, entanglement. Entanglement is nothing but at a time, if a particular value is measured in qubits, so all the remaining bits at a time connected together and all will be changed like a magical dice. So unique property where two qubits become linked, that we can say. Changing one qubit instantly offers that instantly affects the other, no matter how far apart they are. They are too long, too much distance also. The one bit change can be affected to other bit change. A pair of magical dice, if you have taken, whenever you roll one, and if you got 6 or 7 like that value, other instantly also 6. Even it's on the other side of the universe also. So that much long distance also, it will automatically link together and it will change. That is the entanglement. Next, interference is the other quantum principle or property which will help us in achieving quality and in achieving fastness. That is the quantum states are like waves here, water waves. So these waves can add up. That is nothing but constructive interference, or cancel out each other. That is destructive interference. So by carefully designing circuits, we amplify correct answers and cancel wrong ones. Okay, we have to carefully design the circuits. Then it will be in a constructive interference, or it may be destructive interference also, cancel out also. So think of two water waves, just to analyze this. Water wave analogy, you can understand this. Sometimes they make bigger wave, sometimes they cancel into flat water. Okay, so sometimes a bigger wave can be formed at the same time. Okay, so the water in two types. No? One is like waves will in sea water we can observe the waves form of water, and in river we can see the flat water. Sometimes they cancel in and form as a flat water. Like this, the interference also like constructive interference or it is a destructive interference. Quantum gates and circuits, these are also discussed in the previous sessions. Okay, just I will just brief up only. Classical gates first we see. Classical gates and are not XOR, that manipulate bits 0 or 1. So these are the classical gates we use in other technologies. Okay, here in quantum computing, we will use quantum gates and quantum circuits. These principles are very important. Why? Because in achieving fastness, mainly the quantum computing is for fastness. The advantage we can get through implementing these above properties and quantum gates circuits. These all we have to consider in any machine learning technique, that may be neural network, already discussed in the previous session. You discussed, you listened just quantum support vector machine or anything. You need these quantum gates, quantum circuits, and these three properties also. Okay, so the X gate, Y gate flips 0 to 1 and 1 to 0. Next, Y gate, like X, but introduces the phase rotation around Y axis. Next, Z gate flips the phase of 1. Next, Hadamard gate transforms 0 plus keta 0 plus keta 1 by root. Next, transform keta 0 minus keta 1 by root 2. So this is nothing but creating a superposition. So next, phase gates, S gate, T gate, phase of pi by 2 to 1. So that is keta 1. So pi by 2 means that is 3.14 by 2. That value to keta 1. Next, T gate, that add phase of pi by 4 to keta 1. So next, multi-qubit gates, that is controlled NOT Next, TOEFL is not control not. It's third qubit of first two are one, like that. Okay, control not is nothing but like that. Next, quantum circuits. Okay, quantum circuit is a diagram representing the sequence of gates on qubits. So horizontal lines, qubits, boxes, operations, gate, that is gates applied. These control operations are C naught and TOEFL, that is C naught and CC naught, we can say simply. Okay, these already you have seen. Next importance we'll see gates allows us construct algorithms, Grover's algorithm, Shor's algorithm. So circuits implement operations like entanglement, superpositions, algorithms which discussed in the previous sessions, the Grover's algorithm and Shor's algorithm. So mainly the circuits meant for these three properties. To achieve these properties, the entanglement, superposition, for quantum computing hardware is nothing but superconducting trapped ions. These all we can say. So next, NISQ era noisy intermediate scale quantum. What is noisy intermediate? Noisy? Noisy is nothing but some error, some disturbance. That is nothing but noise. Here, quantum systems today are prone to errors that is easily affected. I am telling about the real-time quantum machines. Real-time quantum machines now what we are using real-time machines. Those are error prone. Those are easily affected to errors. Why? Because so this quantum computing now is in at very early stage. The research is going on. So the research just now started. It is going on. So this is nothing but long back when computers before in a large room like that with large processors like that. No? So in the same way, the quantum computer, quantum machine, what we can say, that is in the initial stage only, very inception stage only. So quantum systems today are prone to errors due to decoherence, gate imperfections, and environmental interference. These are the three reasons for the noisy. So the decoherence is one thing, separation. Next, gate imperfections. These quantum gates, what we are using, those gates imperfections, and very what we can say. Drawback that we can say in quantum computing. Why? Because quantum machine has to be in a way such that it should be in an environment of minus 263 degrees temperature. Everything will be connected to each other. That how it is connected means that machine we can see. Okay, that is okay. This is the machine. Okay, quantum computing. Okay, quantum machine or quantum computer, what we can say. Okay, so this is available in only very less number of places in India. That is Amaravati, AP. In Amaravati, AP, recently CM AP CM Chandrababu Naidu Quantum Valley established. So that is the real-time quantum machine. So next we are having Bangalore we are having one, Delhi we are having one, and these are the only what we can say real-time quantum machines, quantum computers existed. So in India, these are real-time machines existed. The CDAC simulators are various simulators we are having in India. Okay, in a number of academic institutions are having that simulators, CDAC simulators. Yes. Okay. So next, What is meant by intermediate scale? So intermediate scale is nothing but refers to 52,000 bits, too large for classical simulation, but not enough for fully fault-tolerant quantum computing. So that 52,000 qubits means here you see one means it is not like general bit 0 or 1, not like that only one possibility. Either it is 0 or either it is 1 in upper bit. It is not like that. Qubit means it is a large number of possibilities, many possibilities it is having. When we have taken 50 qubits, it is too large for classical simulation, but not enough for fully fault-tolerant quantum computing. So the next quantum means exploits quantum properties such as what we discussed, the properties superposition, entanglement, and interference. So these all properties comes under quantum. That's why it is a noisy intermediate scale quantum, NISQ. This is a quantum machine, quantum real-time quantum machine. Okay, in very less number of quantum machines or quantum process computers we are having. In throughout the world, we are having approximately 100. Okay, near to 100 or more than 100, like that only. We are having real-time quantum computers, quantum process. So why quantum machining? Why we have to learn the quantum machine learning? So this quantum is having these many difficulties in real time when compared with. Okay, so why we are combining this quantum along with this machine learning? So not only machine learning, quantum can combine with now research is going on deep learning techniques. We can combine with quantum and AI models. We can combine with the quantum principles. Okay, so the first why this machine learning quantum combination is needed, that we will discuss. Limitations of classical ML with large data, that is the one problem. Classical machine learning models face significant limitations when dealing with large data sets due to computational, algorithmic, and data-related constraints. Conditions. When we are dealing with ML, we are having large data. Those large data, when we are applying to the method, at that time, now after the number of devices, smart devices, when the technology era came, then the data is becoming larger and larger and larger. That's why we are studying data science also, about the data. So that's why we are using cloud now. So unlike modern deep learning models, many traditional algorithms were not designed for the volume, velocity, and variety of big data. So when we went to deep learning and AI models, then we can see those can support capacity, very big data easily, but these machine learning models cannot afford those and support these machine learning techniques are not support with these. That's why quantum we are combining with the machine learning models, machine learning techniques. Quantum, why we are adding means it speed ups, offer the potential to solve the optimization and pattern recognition problems significantly faster than classical computers for specific well-defined tasks. The advantage root from leveraging unique quantum mechanical properties such as superposition. These properties are very helpful for us. Superposition, entanglement, and interference properties, along with those quantum gates and quantum circuits. So now this is the speed ups for optimization and pattern recognition. This is the main advantage of quantum. Okay, quantum is mainly for only fastness. That fastness is when okay, already you are having idea in the last session, so you may listen about the speed of the quantum machine. When years of years, 8 years, supercomputer has taken to can be the go through what collect the data, it will take just minutes of time. That much very fastness. Okay, even it is having many drawbacks in real time. Okay, but we are preferring that we are research is going on because of the advantages of the quantum computing. Approaches classical plus quantum. This hybrid classical quantum computing combines the strength of both systems to solve complex problems. A method that is particularly effective with current. So in this iterative feedback loop, quantum process handle specific tasks that exploit quantum mechanical properties, while classical computers manage other processes like data preparation, optimization, and error mitigation. See the beauty of hybrid approach here, classical and quantum, both flavors we are having here. So with these both properties, the properties, what we preparation we are getting, the pre-processing, what data cleaning, data integration, transformation. These properties we are having with the classic, which we are already having these properties. Next, optimization, the best also we can get. Okay, the data can be filtered and the data in uniform state, okay, and integrated uniform state. Okay, so and within fixed range of values we can get the data, so that we can get through classical computers. And error mitigation also, reduce the impact of errors also we can get through classical computers. When come to the quantum, so quantum is having these drawbacks, that error mitigation is the main problem there. So that can be solved by this classical computers combination. That is hybrid approach advantage. Next, building quantum machine learning model workflow, how it will be, we'll see. Data pre-processing, the data pre-processing is same. So data when we are taking, so we'll process the data, we'll clean the data, that data having any erroneous values, exceptional values, miscellaneous values, okay, that is a wrong values, empty values, or redundant values, like that, coding into qubits. For feature extraction, we have to data and we have to encode the data. That data encoding into qubits, that we will do next. Data can be transformed into qubits. Designing the quantum circuit. Okay, so how to design quantum circuit already have seen. Okay, next, choosing optimizer. Next, training the model. Next, testing and evaluation. These are the steps in the building quantum ML model. So IBM QSkit overview we will see. So open source software development kit for quantum computing. So there are several powerful open source software development kits are available for quantum computing, with the most popular being QSkit. Okay, these SDKs, software development kits, allow developers to design, simulate, and execute quantum algorithms on classical simulators via cloud services mainly. So we can, this software development kits, on real-time machines also, real-time quantum process also. Quantum processes are very difficult to work on. To get the slot is difficult for us. Okay, we have to any academic institution book a slot and then we have to work. Okay, so difficult. That's why here this software development kits allow developers like us to design, simulate, and execute these quantum algorithms on classical simulators via cloud. Okay, we can use the IBM cloud. This IBM cloud by IBM. This QSkit is one of the software development kit developed by IBM only. It is a highly popular and performant open source SDK that uses Python to manage operators and primitives. Python language, for machine learning, we are preferring Python. Not only machine learning, for any complex deep learning, all techniques we are using Python only. Platform is Python based. What are the key features for QSkit is nothing but here I was not written the features. So just features the bag agnostic feature that QSkit supports quantum hardware and simulators, Amazon bracket, and many more. Modular architecture. So this QSkit properties, just I will explain briefly. Modular architecture means it consists of several modules, including QSkit software development kit for core functionality, QSkit Air for high performance simulation with noise, and QSkit runtime for optimized execution of IBM's cloud. This is the modular architecture. These are the properties of the QSkit. Mainly the QSkit software development kit. Why we are discussing in this session is nothing but it is having these many yes, and these many features it is having. And also it is having optimization tools. The best solution can be costly. For that we are having supporting tools in quantum. This in transpiler optimizes circuits for specific hardware, reducing gate counts and circuit depth. Okay, that is when gate counts reduced and circuit depth reduced, automatically it improves the optimacy. Okay, it is giving the best. The number of circuits reduced means gates reduced means complexity will be reduced. Next use cases, when we have seen the use cases regarding this QSkit, algorithm development, optimization, chemistry, and quantum machine learning. These all are the use cases are nothing but these are all are the involving components we can say. So one is the development, next optimization, next chemistry. The main application of the QSkit and quantum ML also chemistry mainly. So why? Because chemical components combination in drug discovery, it will take, we know that drug discovery is a very complex process in medicine preparation. It will take. Okay, so usually for a medicine, it will take 5 years, 6 years, 7 years like that. In without that protocols, without that proper strategy, in COVID time we have seen many companies came with different medicines without that strategy, time complexity of COVID medicine. Without that, so many companies, Bharat Biotech. Also, we are having the great contribution from Bharat Biotech. From that, within short span, COVID vaccine has been released. After that, so many vaccines are released from so many countries. But this has been in very short time. But there is no there in COVID time. That's why it went like that without any procedure. Okay, as much as fast as seen time problems when, or when you have taken problem statement in writing paper also, you observe how difficult it is drug discovery, how much time it will take, you can understand. So the next components we will see Terra, Air, Aqua. These are the components of IBM QSkit. QSkit quantum computing was historically structured around four original components named classical elements: terra, air, ignis, and aqua. So in this mainly these three what I mentioned here are more advantages. This architecture has since evolved to be more modular. Specifically, aqua has been disapproved. Why aqua has been disapproved? I will tell you. So, and its functionalities for machine learning and optimization have been migrated into dedicated packages. Terra, so creation and optimization. So this Terra QSkit component, first component Terra is low-level functions. It takes care about the low-level functions of the quantum circuit. Next, it focuses on the circuit building. It provides core quantum circuit class for assembling quantum circuits using wide range of quantum gates. So I am again not discussing quantum gates and circuits. Why? Because already these gates and circuits are covered in the previous sessions. Transpiler, this essential component optimizes a user circuit for a specific quantum such as its available gates and qubit connectivity. Next, management. Terra handles execution of quantum programs on either local simulators or remote quantum hardware through a standardized interface. The main job of the Terra is nothing but execution of quantum programs, quantum algorithms, quantum machine learning algorithms, quantum machine learning, any machine learning, but what we discussed the artificial neural network from there to from neural networks initial to the next back propagation like that. Those all neural networks to support vector machine like that. Neural network like the deep learning techniques also we can handle with QSkit. So in mainly QSkit, Terra is advantage. So air, when we see is QSkit's high performance. So this is each one is having some is this convolution networks and all this will be useful. Next, air is a high performance simulator designed to emulate quantum circuits on classical computers. High performance simulation core. The code is written in C++ for speed, allowing developers to test and debug algorithms locally before running them on actual limited quantum hardware. Complex algorithms in C++, we have to many thousands lines of code by feel difficulty. That's in QSkit, the coding is written in C++ for maintaining the speed and allowing developer to test debug algorithms locally before running them on actual limited quantum hardware. Okay, see, we are combining both advantages. In classical, what we are having advantages. Okay, the debugging algorithms, okay, error, rectifying errors. Not only provided okay, so we are having Google also provides quantum simulators. Okay, also providing incorporate a realistic characteristic of real quantum processor. This is crucial for studying the performance of algorithms in the current noisy intermediate scale quantum era. Why? Because in quantum main, I told you already, main very error prone. There, all precautions have been taken, so that a computer processor where is the room, any vehicle went, impact also destructs or collapse entire quantum processor, very much big quantum. From first stage of computer, now we came to, okay, so that much is silly. So that's why in future quantum uh, real time, what are the difficulty we are facing? Those difficulty will be reduced. That will be done easily. Auxiliary backend is also one. It includes tasks such as state vector simulators, different vectors. Okay, okay. Next, QSkit Aqua. Up to this, we are going to the Aqua. So Aqua is nothing but ML and optimization. It mainly concentrates on. Originally, was high-level library for quantum algorithms and applications. It was deprecated in 2021. Okay, only 4 years back. Application packages. That is functionality migration. The algorithms and tools once bundled with Aqua have been moved to other QSkit algorithms. Quantum neural, quantum neural networks and support vector classifiers. Next, QSkit optimization to optimization problems. So now how we see features what we can get through cloud. Access to IBM's computing processors and high performance simulators using the open source QSkit software development based graphical interface. Based, okay, start QSkit SDK. Okay, start down IBM ID way. Next, you can are available flex offers later it will suggest to go for I think IBM Quantum AI Cloud QSKIT you have to okay you have zero benefit wide number of. So is ML models, any ML models. Next, cyber security and cryptography. Cyber security also very much okay, very much more research focused area. So in cyber security also, it will be very much useful. Quantum machine learning methods and network security and cyber security in both. Okay, why? Because RSA algorithm, if you have taken RSA algorithm to break it, in machine learning concepts, if you have taken, it will take many years. That RSA algorithm can be breaked by quantum machine learning technique. Okay, if you have used any machine learning method, quantum machine learning method, it will take just minutes. That you can understand how it is differs cyber security and cryptography network security. The RSA algorithm, how it is breaking is very much difficult. Okay, so but using a quantum ML, you can do within fraction of minutes. You can break that. Okay, next, natural language processing. Okay, so the sentimental analysis, data sentimental analysis, that is also okay, one of the big application. Optimization problems. So optimization, the best solution it is giving. Next, financial modeling also, quantum time series prediction and risk modeling. Okay, so this mainly stock market prediction, this much very much useful. This is very much useful. The first QCNN architecture was proposed in 2019. Okay, this is a research regarding that highlights I'm discussing. In 2019, Kong, Choi, Lukin, the first QCNN architecture was proposed. Next, QCNNs have been implemented on IBM Quantum and Google Quantum AI platforms using frameworks like QI's Kit and Penny Lane. These are okay. IBM Quantum is good only, but okay. So many are using Google Quantum AI also as platform. Frameworks are using uh, QSkit and Penny Lane. Penny Lane is from Google Quantum AI. So and this IBM Quantum is a QSkit. Okay, challenges and future directions are hardware limitations, mainly in quantum computing. The main drawback is noise and decoherence, we already discussed. In coming years, we hope everything will be resolved. Okay, so in future we will see not like normal computers, normal laptops, and mobile smartphones, we are seeing in the same way. We can expect. Okay, next, scaling quantum machine learning algorithms. That is also one challenge. Next, integration with classical ML pipelines. Okay, integration we have to do carefully. Classical principles, machine learning principles, along with the quantum computing principles, that gates and circuits when you are connecting, it is very much carefully you have to do. Next, research opportunities. Plenty of research opportunities are there. If you applied for any DSC project or any other funding project, okay, so you can it very much costly actually when you compared with the other type of technologies. Even crores, okay, you have to put a 2 crores, 1.5 crore, like that. The budget will be high for this quantum computing related research projects if you have taken. This is about the challenges and future directions. A summary: mainly the quantum computing offers machine learning breakthroughs. QSkit provides practical hands-on tools. Hybrid approaches are the near future. Opportunities in academia and industry. This is about today's session. Okay, so along with this, I am sharing one GitHub code with you. Um, Madam, can you please share that GitHub code? I will share you that you share to listeners. Why? Because some see understanding. I covered mostly what are the layers are doing in each and every layer, what it is happening. Theoretically, I described, but that GitHub link will give the how quantum gates and quantum circuits are working in each and every layer. Okay, madam. That is from my side. Anybody having any doubts, you can ask me. No, ma'am. Yes, madam. I will also do one. Madam, I switch on my camera. Yes, madam. So camera is problem something I am not getting. Okay. Now it is coming, madam. Okay, okay. Madam, thank you, madam. Thank you very much. All the listeners also thank you very much for your patience. There is plenty opportunity there are plenty of opportunities in quantum computing. It is just upgrowing. So I am suggesting all of you to go through quantum. Okay, as now we are mainly going through machine learning, deep learning, AI. Along with that, it is very very okay upcoming, okay, area. Okay, when you combine this, okay, so the in while paper writing or it may be project, it will be more beneficial to us.